By 2025, the whole world will be enveloped in freaky auroras that'll cause planes to start dropping out of the sky. By 2027, ocean levels will rise and drown cities like New York, San Francisco, Los Angeles, and Miami. And in 2030, the ozone layer will collapse, leading to mass extinction. All these horrors are supposedly because Earth's magnetic poles are going to flip. If you've also seen videos like these, drop a comment below. Meanwhile, I decided to dig into what these forecasts really mean. But once I got into the actual scientific research on changes in the magnetic field, it stopped being funny for a whole different set of reasons. So, let's get to the bottom of this once and for all. Could Earth's magnetic field really kill us? First off, I was shocked to learn that scientists still don't know exactly how Earth's magnetic field came to be. Since other terrestrial planets in the solar system don't have similar fields, ours looks like a total oddball. So where did it come from? The prevailing theory is that inside our planet, there are two cores, an inner solid one made of an iron-nickel alloy and an outer liquid one made of molten rock. The second, liquid core slowly cools down and releases heat waves that rise and create a convection flow. Thanks to Earth's rotation, these flows spiral and generate a magnetic field around the entire planet. Basically, it works just like a dynamo bike light. Remember this bit about the core because it's going to be super important later on. But how did this magnetic machine under our feet even get started? There's a theory that 4.5 billion years ago, a Mars-sized planet named Theia crashed into Earth. The impact sent part of our planet into orbit, becoming the Moon, and Theia's core merged with Earth. Its remnants are located beneath West Africa and the Pacific Ocean, and it's the densest object in our planet's mantle. Some scientists speculate that the energy from that collision, along with the iron-rich fragments of Theia, if not kick-started, then at least significantly boosted Earth's magnetic field. However, even the top experts in the field can't explain why the magnetic poles never match up with the geographical ones, even though, because of Earth's rotation, they totally should. Since their first discovery, the magnetic poles have been shifting northwest by an average of 40 kilometers per year. But then, this process really picked up speed. Throughout the 20th century, the North Pole shifted by over 1,000 kilometers, and in the last 40 years, its movement speed has increased almost sixfold. And it's happening in fits and starts, but why? In 2019, scientists created a computer model of the magnetic pole shift. They concluded that the cause might lie in warm hydromagnetic waves rising to the surface from the outer core and getting amplified within it. It's like resonance when a rotating object shakes itself, but a definitive answer remains elusive as they only use data on pole movement since the 1970s. Meanwhile, some scientists outright doubt that the Earth's core has anything to do with creating the magnetic field. Professor Gregory Riskin from the McCormick School of Engineering and Science believes Earth's magnetic field is actually created by the oceans. Sounds crazy, right? But Riskin points out that salty water conducts electricity well and is constantly in motion. So, changes in the North Atlantic currents could be linked to the jerky movement of the magnetic poles. Mind blown yet? The fact remains, the scientific community doesn't have clear answers about the nature and behavior of the magnetic field. And that's kind of spooky. At least scientists have figured out that the magnetic field has changed and caused cataclysms in the past. Recently, archaeologists analyzing the composition of Mesopotamian clay tablets noticed that the iron particles in them are magnetized. This means 3,000 years ago, Earth's magnetic field was almost 3 times as strong as it is now. Similar anomalies have been observed in artifacts from China, Bulgaria, and the Azores. And there's no explanation. However, ancient people couldn't have felt this steroid-pumped magnetic field because they didn't have electronic devices. But everything changed at the end of August in 1859 when a young English astronomer, Richard Carrington, witnessed with his own eyes an incredibly powerful solar flare. As it interacted with Earth's magnetic field, which usually shields us from such emissions, the burst of charged plasma triggered an unprecedented geomagnetic storm. The night in America turned into day due to the green and crimson flashes in the sky. Such auroras are usually only seen in Arctic latitudes, but back then, they were even spotted in Cuba, Jamaica, and Hawaii. Meanwhile, the telegraph, essentially the internet of that era, just shut down, with machines sparking, scorching telegraph operators, and burning holes in the paper. That was the first documented solar superstorm that triggered the most intense geomagnetic storm in recorded history. According to scientists' forecasts, a similar event may await us in the near future, as the sun has been quite active over the last 3 years. According to scientists' predictions, the peak of solar activity might hit in 2025. If a powerful flare hits Earth, the magnetic field will generate electrical currents near the planet's surface. If they are too strong, even turned-off electronics could malfunction. That sounds terrifying. But what about those mass extinctions from those apocalyptic forecasts? Well, it's complicated. Scientists from the University of Liverpool studied the cyclic changes in the magnetic field over millions of years through ancient lava flows at Strathmore and Kinghorn in eastern Scotland. As it turned out, about 120 million years ago, the intensity of the geomagnetic field was less than a quarter of what it is today. Scientists have dubbed this period the mid-Paleozoic dipole low, and it's just part of a cycle that lasts 200 million years. Throughout it, the magnetic field fluctuates from very weak to anomalously strong, like back then in Mesopotamia. Yet, the consequences of such fluctuations for life on Earth are practically unstudied. However, some scientists believe that the mass extinction at the boundary of the Devonian and Carboniferous periods, 359 million years ago, occurred due to an increased level of the sun's ultraviolet radiation coinciding with the weakest readings of the magnetic field at that time. That is, it couldn't protect the ozone layer from solar wind and cosmic radiation, causing harm to living beings. But the apocalyptic forecasts talk not about weakening magnetic fields, but about them swapping places. And here, I must say, the so-called magnetic field reversal is, to put it mildly, overrated. You've probably heard about the Adam and Eve story, the book by engineer and ethologist Chan Thomas. In it, he promotes the idea of simultaneous shifts in the magnetic poles and Earth's crust. Basically, along with them, Earth's surface shifts as well. According to Chan Thomas, this triggered massive earthquakes and volcanic eruptions 7,000 years ago. Giant tsunamis slammed the coastlines, and all land was completely submerged underwater for several days. That's the ultimate Great Flood. This apocalyptic scenario even made its way into the disaster movie 2012. But from a scientific standpoint, it's a total no-go. You see, a pole shift doesn't mean Earth's crust gets shuffled around. It's stuck too tight to the mantle. Plus, scientists have concluded that in the last 83 million years, the poles have flipped places at least 183 times without any catastrophic events tagging along. So, on average, a pole flip happens every 450,000 years. But get this, the last time it could have happened was roughly 780,000 years ago. Apparently, modern humans have never experienced. A pole reversal is seriously overdue, causing uncertainty in predictions. For the magnetic poles to flip, the field first has to weaken significantly, nearly disappearing. Over the last 3,000 years, it has weakened by 30%, but for the poles to swap places, this drop needs to reach at least 90%. Current forecasts suggest this won't happen in 2025, but more likely in 3025. While we won't witness planes falling out of the sky anytime soon, even then, it would probably not threaten all life on Earth, just electronics. As the creator of the Riddle channel, with dozens of videos about apocalypses, I didn't stop there. I wondered what if the weakening of the magnetic field doesn't stop at 90%. Here's the real deal on a magnetic apocalypse that you won't hear about in viral videos. Remember I mentioned that information about Earth's inner structure would be crucial? This is it. In January 2023, researchers from Peking University, Zhi Xiaodong Song and Yi Yang, noticed something super odd about Earth's inner solid core. In 2009, it practically stopped and then started moving in the opposite direction to Earth's rotation. Scientists think this process works like a swing, and the next time the core will change its movement direction will be shortly after 2040. But since we don't fully understand how the magnetic field is generated, what if these inner processes don't just weaken but outright switch off the magnetic field? In the South Atlantic, there's a zone where the magnetic field is weirdly weak, and this hole is gradually getting bigger. No one knows exactly why, but because of it, space missions steer clear of the area as their gear could go haywire due to charged particles the magnetic field no longer wards off. If this anomaly were to spread across the planet, meaning the field shuts down entirely, well, Houston, we'd have a massive problem, and not just Houston. Right now, Earth's magnetic field traps charged particles from solar winds, creating what's known as the Van Allen radiation belts. For decades, these belts have been a big headache for any spacecraft trying to reach far orbit because the radiation levels in these zones are 10 times higher than at nuclear power plants. If the magnetic field suddenly shuts down, the Van Allen belts will vanish as well. This is bad news for NASA. Without natural protection, satellites and astronauts aboard the International Space Station would literally fry. Forget about the Artemis moon mission and actually any space travel for the next few centuries. Getting around on Earth won't be any easier since GPS satellites would be toasted. Even old-school compasses won't save us because they'll point not to the north, but to whatever's got the nearest source of magnetism, like iron ore deposits. It's not just us losing our way. Birds that navigate by magnetic lines will get lost during migrations, while sea turtles and lobsters will aimlessly wander the seas. Their potential die-off is just the beginning. Insects will lose their bearings and fail to pollinate plants, breaking food chains and leading to famine. Coordinating to redistribute scarce resources would be impossible due to a total tech collapse from the next solar flare like the Carrington event of 1859. Without a magnetic field, charged plasma would hit our electrical devices directly, resulting in no more communication or electricity. As if that's not bad enough, the sun would wipe out the ozone layer, leaving us to slowly roast under its ultraviolet rays. Picture a beach day so scorching that no sunscreen can save you, and skin cancer starts on the spot. Moreover, over the next few centuries, the solar wind would gradually blow away Earth's atmosphere, meeting no resistance from the magnetic field. This already happened to Mars when its magnetic field shut down, so Earth would become much more like the red planet, deserts, cold, and very little oxygen. Stepping outside, you'd start freezing and gasping for air as if you're at the top of Mount Everest. Now, that's a real apocalyptic scenario no one seems to talk about, unlike those made-up disasters from a pole reversal. So yes, the magnetic field can indeed kill us, but only if it disappears entirely. However, scientists can't say for sure how likely this scenario is because they're still not even sure how the field forms in the first place. If it actually disappears, is there a way to reboot it? Scientists are already developing a similar project for Mars. They plan to chuck an asteroid at it to create a moon-like satellite. After that, they'll heat up the core with a series of underground nuclear explosions. Sounds epic, doesn't it? But something tells me we wouldn't want to try that on Earth. So let's appreciate our magnetic field for being there and reliably protecting us from death, except, of course, when it tries to mess with our electronics during solar flares. Drop a comment below if you think you could survive a few years without the internet, and don't forget to subscribe to the channel so you won't miss the real predictions about future disasters.